This video will work through problem 8.1 in Gapenski's Healthcare Finance, 6th edition. Okay, in 8.1, we're presented with a statistics, flexible, and actual budget for a notional hospital. And remember, your statistics budget is your expectations. So you're using your expected prices for your revenues times your expected volumes. And then you're going to I use PE again for costs. So this would be, whereas this is the price of your outputs, this is going to be the price of your inputs. But you're basically saying I'm using the expected amount of money I'm going to spend per unit to generate the expected volume, right? So expected times expected gives me both expected revenue and expected costs. Revenue minus cost gives me profit. Over here on the actual, so the statistics budget is what we think we're going to have before the year begins. Then you get your actual, which is what actually happened over the course of the year. And this time, instead of using your expected prices and your expected volume, you now have what actually happened. So you have the actual prices that you charged per actual unit that you produced to generate your revenue. You have the actual prices that you paid per unit of input times the actual volume that you did to get you your costs. And then you take your actual revenue minus your actual costs to get your actual profit. Now, flex, if you remember from the chapter, is kind of a mashup of your statistics budget and your actual budget, where the flex budget takes the expected prices that you thought you were going to get for each of these. So it takes the same expected price for revenue, the same expected price of the inputs for the costs, and then it multiplies it by the actual volumes that you actually got, right? And so the difference between the stat and the flex numbers is volume. So the difference here is volume. And then between flex and actual, if you look here, we're using actual volume and actual volume, the difference between flex and actual is price. I'm gonna have to get myself a new marker here. Right? So when we compare stat to flex, it allows us to compare the result of the differences in volume while holding price constant. And over here, it allows us to compare the impact of expected price versus actual price holding volume constant. So it allows us to basically focus in on volume, the impact of volume between these two, and the impact of price between these two. So part A asks us to calculate and interpret the profit variance. Okay, so the profit variance is going to equal the actual profit. Let's call that profit actual, so profit sub A, minus profit stat. So we'll take 0.3 minus 0.6, and that gets us 0.3 minus 0.6, negative 0.3, or 300,000, right? Because these are in millions. So we have a profit variance of negative 300,000. So what does this mean? Well, we had a goal of earning $600,000 in profit. We actually earned $300,000 in profit. So we had a shortfall of profit of $300,000. So the negative number here means we fell short of our goals. Now, part B asks us to calculate the revenue variance. Let me switch out a little bit of paper here. So revenue variance is going to equal the revenue actual minus the revenue stat. And so we have 4.5 million minus 4.7 million, which gives us negative 0.2 million. So that means that our revenues fell $200,000 short of our target. We thought we would earn 4.7 million. We actually earned 4.5 million. And then doing the same thing for cost, go like this. So part C asks us to calculate the cost variance. Cost variance is going to equal the statistics cost minus the actual cost. Now, we flipped that, right? Because before I was taking actual minus statistic. Now I'm flipping and I'm saying statistic cost minus actual cost. So why am I doing that? Well, the idea here is that, remember, with revenue variance, what I really would prefer is for revenue, the actual revenue, if I'm going to have variance, I'd like to have the actual revenue be bigger than the statistics revenue, meaning I'd like to have the actual revenue be bigger than the amount of revenue that I thought I would earn. So if we wind up with a positive revenue variance, it means we earn more revenue than we thought we were going to earn. That's a surprise, but at least it's a good surprise. Here, I'm taking the actual cost from the projected cost, because if I wind up with a positive number here, what that means is I projected some amount of cost and I wound up with spending less money than I thought I would. That's a positive surprise, so that would generate a positive number. So if my expected cost, my statistics cost was say 10, and my actual cost was 8, I would have 10 minus 8 would be positive 2, right? So that would be a positive surprise. So the idea is the valence of the variance. If it's negative, it tells you that's a bad thing, right? Bad variance. And if it's a positive, it's a positive variance. So in this case, we thought we were going to spend 4.1 million. We actually spent 4.2 million. So that's a negative variance of negative 0.1, which means that we spent more than we thought we would, right? So the amount we spent, 4.2, is greater than the amount we projected. And as a result, we get a negative cost variance, meaning we spent more than we thought we would. So when we add those together, right, we have cost variance of negative 0.1 and revenue variance of negative 0.2, we wind up with negative 0.3. So when we add the cost variance and the revenue variance together, we get the profit variance, right, of negative 0.3. So, so where did that negative 0.3 profit variance come from? Well, part of it came from not earning as much revenue as we thought we would get, and then spending more than we thought we would. Part D asks us to calculate the volume and price variances on the revenue side. Okay, so volume variance on the revenue side for revenue is going to be the revenue flex minus the revenue statistic. So revenue flex is 4.8 minus stat 4.7 gives us a positive 0.1, right? And volume variance, remember, the difference between flex and stat is we vary the volume, hence the volume variance, right? So the difference between stat and flex is we're holding price constant and we're allowing volume to vary. And so the change in revenue variance or the revenue variance comes in part from the volume variance. So we have a negative 0.2. Remember, revenue variance was negative 0.2. So we have a positive 0.1 volume variance. And then to get the price variance on the revenue side, we're going to, so with price, we want to look where the price varies. So the price varies between the flex and the actual, right? We use the expected price for the flex and we use the actual price for the actual, but we use the actual volume for both. So the price variance with respect to revenue is revenue actual minus revenue flex. So revenue actual was 4.2 and revenue flex was 4.1. Sorry, yes, 4.1. Sorry, mistake there. Let me correct that. Actual revenue was 4.5 and revenue flex was 4.8. I grabbed the data off of the cost line, so we'll do that in a minute. So the price variance with respect to revenue is 4.5 minus 4.8, which is negative 0.3. If we add those two together, so revenue variance decomposes into volume variance plus price variance. So revenue variance was negative 0.2, volume variance was positive 0.1, but price variance was negative 0.3. When we add 0.1 to negative 0.3, we get 0.2. Next, we're asked to calculate and interpret the volume and management variances on the cost side. Okay, so remember, cost variance was cost stat minus cost actual, which in this case is 4.1 minus 4.2, which gave us negative 0.1, right? Cost variance breaks down into volume variance and management variance, which is really price variance. But we're calling it management variance when we talk about costs because one of the things that managers are supposed to be able to manage is the price of the inputs that they're using. So to get the volume variance for the cost side, we're going to look for the two columns that hold price constant and allow volume to vary. That's the stat and flex. So volume variance on the cost side is going to be cost stat minus cost flex. So cost stat is 4.1. Cost flex is 4.1. So we have a zero volume variance. Our price variance then, or management variance, is going to be the two columns that allow price to vary and hold volume constant. So that's going to be flex and actual. So we're going to take cost flex minus cost actual, and cost flex is 4.1, cost actual is 4.2. So 4.1 minus 4.2 gives us negative 0.1, which matches back to our original cost variance, right? So when we add the volume variance and the management variance together, 0 plus negative 0.1, we get negative 0.1, which matches the original cost variance. All right, and so part F says, how are the variances related? So we've already kind of talked about this at the beginning. and really the book answer basically goes back through the relationship I described before. You're going to share volumes between, you're going to have an expected volume that's going to drive both revenue and cost. You're going to have an actual volume that drives revenues and costs. And then when we compare across columns, we hold prices constant at expected prices constant between stat and flex, which allows us to vary volume, which allows us to estimate the impact of changes in volume. When we move from flex to actual, we keep the volumes constant and vary the price. That allows us to estimate the impact of a price change.